Hey folks, welcome to our video series on the senses. This week we're going to talk about how the brain interprets where we are in the world and what's going on around us. So the sensory system can be broken up into two divisions. We have our general sense organs and we have our special sense organs. The general sense organs are sense receptors that can be found all over the body, in pretty much every type of tissue or organ. Their job is to sense things like pain, pressure, stretching, or temperature. So if you have a big meal and you feel bloated, that's the stretch receptors in your stomach telling your brain that you're full. Special sense organs are a little bit more complicated. They're a sophisticated group of tissues and cells that can detect very specific things, like sound waves, smells, and light. Whether general or special sense organs, the basic premise is still the same. The sense organ detects a stimulus. It could be pressure, light, smell, it just depends. And then it takes that external stimulus and it converts it to an electrical stimulus so that the nerve cells can transmit that information back to the brain. When looking at sense receptors, we'll often categorize them by the types of stimulus they react to. Photoreceptors respond to light, chemoreceptors respond to chemicals, nociceptors respond to injury, thermoreceptors respond to temperature change, mechanoreceptors to movement, and proprioreceptors to the position of the body parts. So here's an example of each of them to help you conceptualize this. Some sense organs will use these in combination as well, so they might use multiple types of receptors. And most organs have multiple types of sense organs. The skin or integumentary system would be an example of a huge general sense organ, full of sense receptors that detect pressure, temperature, and pain. So all sense organs, no matter what they detect, work generally the same way. They detect a stimulus, convert it to an electrical impulse, and send it to the brain through a particular nerve. Our goal for this course is for each special organ to recognize what the stimulus is, how the organ converts it, and specifically what nerve is used to transport it to the brain. Alright, so let's start looking at some specialized sense organs. It's breakfast time while I'm recording this, so let's talk about smell and taste. First off, both organs recognize chemicals, so they are full of chemoreceptors. In the case of the tongue, it's full of these small bumps and divots called papillae. These papillae have two functions. One is to hold on to the food. Check out this tiger's tongue. The papillae are pretty wild. And the other is to hold our taste buds, which is what we're really interested in today. The taste buds, otherwise known as gustatory cells, are where the chemoreceptors are located in the tongue. On top of the cells are gustatory hairs, which react to different chemicals, and then the conversion from chemical to electrical stimulus happens inside the gustatory cell itself. The gustatory cells in the tongue react to different chemicals, or in this case flavors, depending on where they're located in the tongue. From there, nerve cells carry the information away to the glossopharyngeal nerve and the facial nerve, which carry information all the way to the brain. The next organ is the nose. I've grouped these together because they work very closely. Your sense of taste is hugely affected by your sense of smell, and vice versa. Don't believe me? Next time you have a stuffed nose, try your favorite food. I bet it's going to taste different. So the nose works kind of similarly to the tongue. Chemicals enter the nose, in this case the air we inhale, and stimulate special cells in the nose called the olfactory cells. Interestingly though, the chemicals can enter from the exterior part of the nose or from the rear passages of the nose called the nasopharynx. Either way, once the chemicals get to the olfactory cells, cilia absorb the chemicals, and then inside the olfactory bulb, it gets converted to electrical energy. From there, it gets sent to the olfactory tract, the olfactory nerve, and then to the brain.